별로 없으신데 늦게 오신 분들은 손해예요. 그 오전에 발표하신 분들이 굉장히 유명하신 분들입니다.
네, 이렇게.
첫 번째 발표는 그 요사이 그 인터넷 오브 띵이 굉장히 뛰지 않습니까? 그래서 사물 인터넷 쪽, 지오스페셜 사물 인터넷 쪽의 권위자이신 캘거리 대학의 스티브 리앙 교수님을 모시고 아주 이걸 얼마나 쉽게 쓸 수 있는지에 대해서 한번 들어보도록 하겠습니다. 그럼 큰 박수로 스티브 리앙 교수를 맞이하도록 하겠습니다. 스티브 리앙 교수.
안녕하세요. That's the only thing I know. And food, I know a lot of food. Tofuchike, that's all the Koreans I know. But it is my honor to be able to have this opportunity to share something I'm very passionate about with you. And I think this is going to change the world, and it will change the world, Internet of Things. And the question right now is, it will be done by you or done to you, because IoT will change everything we do, the way we live, we play, and we work. Okay? And then I think IoT, geospatial location, is a first-class citizen. It's very important for everything, because everything without location and time, the information collected by the sensors are useless, right? So hopefully today I can share this with you. And then, how many of you have heard OGC, Open Geospatial Consortium? Okay, some of you. So OGC is the standard consortium to make the international open standard in the geospatial world. So if you have a smartphone, you are using OGC standard. And OGC has a very long history in IoT, or it's called sensor web. So today is the other thing I'm going to share with you. I'm very biased because I'm the author of the standard. Okay, let's dive in. Okay, so a little bit about me. I'm a professor, and then I held a research chair sponsored by Microsoft Research, and then I'm also active in international standards, including OGC, ISO, and ITUT in the United Nations. I also have a company called Sensor Up. The reason I'm starting a company is because I'm sick of only have a standard but no code, no software to do that. So people complain about OGC standard is just a whole bunch of theoretical stuff, difficult to use. I'm sick of it, so I decided to put my house and the risk of my marriage and do this and start my own company. Okay, so here's the story. This is my son, Noah. He was born November 9th last year. So as an IoT person or sensor web person, of course, the first thing I do is put sensors all over in the nursery and on my son. Okay, so I had one problem, which is in the nursery, the room of my son, I have so many sensors in it: temperature, humidity, sound, video, camera, movement. Even I observe the the swing, right? What's the acceleration for the swing, right? Really quantify my son. However, guess what? How many apps do I have for the sensors in my son's room? The number of apps on my smartphone is more than the number of sensors on my son and in his room. That's ridiculous, right? Think about your smart home. How many apps do you have? In order to turn on your light, how many apps are you going to use? This is crazy. So this is called IoT value chain. That means if you want to develop any IoT applications, you need to go through these steps. So the first step is sensor and actuator. Identify what sensor are going to use, right? For example, if you have a temperature sensor, like in my son's room, so the first thing is select, okay, it's a temperature sensor. The second step is called smart things. That means you need a CPU or microprocessor, MCU or NPU, and then able to get the message, the signal from the sensor, and convert into a digital signal. It can be analog, for example, and then into digital signal, and transmit it. So it has a network capability and transmit over the network. The third step is network. A network means Wi-Fi, can be 4G, 5G, or the opposite. Have you heard any of you heard of LoRa or Sigfox or LB-WAN? These are the IoT specific network. So again, Internet of Things, you need a network. Makes sense, right? And the fourth step is you need a cloud to host the data. right? To manage the data, visualize the data, to share the data, so you need an API. It's called Device Cloud API. And the fifth is you need a data analytics, right? I use the term very loosely. That means somewhere in the cloud. But finally, sixth step, you need, for any application, you need an API, interface a data model, so that you can consume the data in analytics. And finally, you have your application. So think about your smartphone app, for example, your smart light, right, to turn it on. And that actually goes through all the 7 steps. Okay. So Sensor Things API is an open standard. So basically it is cover number 2, number 4, and number 6 and 7. So that means these steps, you use an open standard. So today, actually one big issue about IoT is silos. Everything system, every IoT system is a silo. They don't talk to each other, right? And then, well, you will say some, Cisco said, use Cisco, so I will connect everything for you. By the way, Samsung also launched a new IoT platform, yeah? And then Samsung acquired SmartThings and launched a new platform. So again, Samsung said, connect to Samsung, I will connect to the world. And IBM says the same thing. And GE, General Electric, say the same thing. And then SAP says the same thing, IBM says the same thing, Amazon and Microsoft. Everybody's in this game, and everybody's building their own proprietary system, and they don't talk to each other. Right? Why? Because they think they can own the Internet of Things. But when you think about today's web, who owns the World Wide Web? Anyone? No, it's an open system. You might say Google owns it, but not really, right? You still, in Korea, you have Naver, right? Right? In China, you have Baidu. Well, Chinese own their Chinese web. Anyway, different story. I'm from Taiwan, so I like to make from China. Okay, so this is a quote. 77% of survey IoT experts think interoperability is the biggest challenge currently facing the Internet of Things. That means everybody trying to own the Internet of Things or develop their own silo. It is unacceptable. This is evil. Don't do that. So, in my opinion, the real value for Internet of Things is about system of systems. It's not from me. It's from Michael Porter, a Harvard professor. Okay. And then that means the value of network is proportional to the square of the number of users in the system or number of nodes in the system. So I strongly believe the more interconnection we can have to connect different things all together, and we have more innovative applications. And I think Internet of Things should be like that, like today's web. Okay, we are in FOSS4G, so we'll see, okay. So let's say open, right? So open source. Is open source a solution for IoT interoperability? Actually, in my opinion, it's part of the solution, but not the solution. Because open source can create its own silo. Actually, there is an open source project, just did the same thing, like IBM, Cisco, GE did. They said, connect to me, I'll connect you to the world. So what does that mean? That means one more system to connect to. You know what I'm saying? Everybody trying to do this, it's one more system to connect to. It's silo. So in my opinion, open source and open standard altogether is a very good, happy relationship. Okay? We cannot live without each other. Because if you adopt an open standard, doing an open source, that means it's truly open. You are not doing another silo and create another thin network. So we need to connect to. So in OGC, we have this API. It's called Sensor Things API. It is so. Okay, I know there's reputation about OGC. OGC standard is difficult to use. Okay, period. We know that. Okay. However, in my opinion, OGC Sensor Things API is very easy to use. So please try it out. Okay. It's RESTful. It's JSON. It provides excellent developer experience. Okay. A little bit detail. So Sensor Things is not a new standard per se. It's an old standard. It's based on a suite of proven working standards. It's called Sensor Web Enablement in the OGC world. And part of it is become ISO standard 19156 2011, and it's I'm one of the authors, anyways. And so this is a very solid foundation. And so this ISO standard or OGC OEM observation measurement is like this. So it's surrounding a concept called observation. Okay. So everything a thing or sensor collect is an observation. You might think for IoT, I only need a time and value, right? So time and the value of the sensor it collect. But no, actually, although most of the IoT platforms out there, they handle time and value, but actually it's not enough. You need more than that. For example, do I have razor later? No, it's okay. In order to use an observation, what do you need? You need a result. That's the first one, right? But if you look at the result, what else do you need? You need phenomenon time. So when you collect the result, right? And what's the time when you collect the result? To describe that phenomenon, you need measurement. You need measurement as well. So in this case, for example, it's a meter per second. And then you need to observe property. So what are you measuring? Are you measuring wind speed or is it car speed, right? For example, let me give you an example. Let's say I joke a lot, so don't be offended, okay? There is a standard called 1 M2M. I think Korea is very heavy behind this. And for 1 M2M, it's really it's from the M2M community. So they think things about data streams, okay? So I make fun of this to the chair of the 1 M2M. I said, when you enter a room, okay, you get a data stream. The data stream gives you temperature. So what? Is it the water temperature of the fish tank in the room, or is your air temperature in the room, or is the body temperature of someone? If you only have a data stream without the contextual information, including location, you don't know what's measuring. You just assume it's air temperature, right? But very possible, it could be the water temperature of your fish tank, which is much lower than your air temperature. Your fish will die. Okay. And also you need the procedure, which is metadata. So what sensor are we using to collect data? And there's one more very important concept called feature of interest. That is the target of your observation. For example, if I have a camera right now here, okay, this is my camera. I'm taking a picture of you. So where's the location of my sensor? Over here. Where's the location of the target of my observation, which is the picture I just took? It's over there. Is it the same location? No. Yeah, it's very important. So think about a Hollywood movie, yeah? Like one of my favorite ones is called Italian Jobs. So you have a whole bunch of cameras, and you have the bad guys driving a truck, and you want to find where the camera looking at the truck, right? It's a complex geospatial query. So do you query the location of the camera or the field of view of the camera? Yeah? You don't query the location of the camera, you query where the camera is looking at. This is very important. So the idea is called feature of interest. However, most of the IoT platforms, they don't have this concept, right? For example, I have a friend, they have a drone company and take a lot of defense business. So they have a drone flying around, and this location is very complicated, right? You just like moving like that. And so cameras also moving like that. But do they care about the drone? No, they care about the image or the video the drone is shooting. Yeah? So in order to describe all these, you need a very comprehensive data model and the API to do that. Okay? So choosing OGC, Central Things API, cover the complex use cases. So there's the data model, UML. So for the data modelers, this slide make you happy. But I'll skip. Okay. One more thing. If you want to develop your IoT system, well, where do you want to spend your time? Do you want to spend your time to integrate different sensor data from different sensors? Or do you want to develop useful applications? This is one more argument why you should use a standard. Because you will find, if you don't use a standard interface, you will find you spend a lot of time just to integrate different sensor sources. For smart home, maybe it's okay. But if you think about smart cities, how many different kinds of sensors in your smart cities applications? Too many, okay? And how about version problem? Today, one sensor network is using like interface 1.0, and in 3 months, 1.1, so to upgrade your code, it won't work, and 1.2. So actually, it can become crazy. Okay, so I'll give you some example. One case study, we did this project with Homeland Security, US Homeland Security, it's an OGC project. And then here is the future of the first responder, of firefighters. Okay, it carries all kinds of sensor on him or her: wearable camera, heartbeat sensor, location, acceleration, headings, equipment status. So that's the future. Yeah, and police will be carrying that too, and the ambulance, EMS, emergency, the medicals will carry that too. So, but as a result, actually, what decision makers want? They want single common operating picture. So one picture, so they can see all the sensor information integrated into one picture. Guess what? How many, for example, in a disaster management or emergency control center, how many screens in front of them? Way too many. But how many do they need? One. Yeah. So this is sponsored by Homeland Security. It's OGC pilot. So the idea is this: in the future, all the first responders, they will use sensors on him, on them, or they can throw sensor away, right? To like drones or temperature sensors. And are they going to use the same system? No, because they have a different budget. And by the way, police and firefighters, they don't like each other, so they won't use the same system. Nobody laugh. Okay. However, how to make this system talk to